One of the aspects of derivatives that's actually a bit unfortunate is that if you have two functions that are being multiplied, you cannot just take the derivative of each function and multiply that together. You can do it when it's the sum and difference of two terms. You can take the derivative separately, but you can't do that with products, and you cannot do it with quotients. So first we'll look at products, and in the next video we're going to look at quotients, which is the division. So you have a product rule, which you'll have to memorize. You have f of x is equal to the product of two function, and then your derivative is going to be, now the reason they're using uppercase F and uppercase S is because uppercase F, they're denoting as the first function in the product, and S, they're denoting it as the second function. So the derivative will be the derivative of the first times the original second plus the original first times the derivative of the second. So let's take a look. Differentiate the following function using the product rule. So the reason I know this is a product, one, the parentheses really helps me with that, right? So I see that there's a term in the front that has an x, and then there's a second term that also has x's in it, and they're being multiplied. So I'm going to use colors a lot in this video. This is F, and this is S. Oh, Christmas. I didn't mean that, but whatever, we're going with it. So f is going to be 5x squared. So f prime, I just need the power rule, it's going to be 10x. And then s will be 3x squared minus 5x plus 2. So s prime will be 6x minus 5. I really advise doing what I'm doing right there on the side, okay? No matter how good I got on the product or quotient rule, if it was high stake, I always wrote my f and my s prime. If you've taken another calculus class before, sometimes they use little f and little g. This is the first time I've seen a book using big F and big S, but it makes sense, like f first and second. I kind of like it. So we have f prime of x. And we're going to have, I'm going to rewrite the formula, f prime s plus fs prime. So this is going to equal to, and if you like, you can do a little x here. That's another reason why it's good too, because they go across from one another. So I have 10x times 3x squared minus 5x plus 2 plus 5x squared, the original f, times 6x minus 5. Now I'm going to clean that up. I'm going to distribute and then combine like terms if I have any. So it's going to be 30x cubed minus 50x squared plus 20x plus 30x cubed minus 25x squared. So my f prime of x will be 60x cubed, so those are gone, minus 75x squared plus 20x. And there it is. Now, in this one, you actually did not have to use the product rule. What you could have done is actually distribute the 5x squared first and then take in the derivative. All right, so sometimes you will have an option, and you'll see in some of the later ones that you don't have an option. But here I wanted to introduce you to the product rule by just using the power rule. Let's do another one. So one of the tricky parts about calculus, especially when you're getting to know all the derivative rules, is to know which rules to use. So just to reiterate, I know I have to use the product rule because I have two terms and they both have an x and they're being multiplied. So let's keep to the same colors. This is F. This is S. So F is equal to 4x cubed. F prime, just the power rule, 12x squared. S is equal to e to the 5x. S prime will be 5e to the 5x. Cross, cross. That means that y prime, I always write a formula when I'm trying to learn it. F prime s plus fs prime. Rewrite it over and over. It doesn't matter if you're doing 10 problems that uses the same formula, just rewrite it 10 times. So this is going to equal to 12x squared e to the 5x plus 4x cubed 5e to the 5x. So this is going to be 12x squared e to the 5x plus, and the 4 and the 5, everything is being multiplied here. So this becomes 20 x cubed, e to the 5x. But this can be factored because they both have a greatest common factor. So this would be term 1, and this would be term 2. So you're going to see what you can take out from both of them. So from 12 and 20, I always do the numbers first. 12 and 20 share a common factor of 4. And then here you're going to have your leftovers separated by plus. So if I take out a 4 from 12, I'll be left with a 3. And 4 from 20, I'll be left with a 5. Then I have x squared and x cubed. So I can only take out the smallest amount. I can take out an x squared. So in this first term, I'll have nothing left. It'll be all gone. And in the second term, I'll have 1x left. And then I can take out an e to the 5x from both. And it'll be gone from both of them. So the e to the 5x will be gone. So nothing will be left in the leftovers. So my factored form, which is very common in calculus, so you're going to have to get used to take out the greatest common factor, is this. All right. And then one great thing about factoring is really easy to check. Just distribute it back in. And if you distribute the 4x squared e to the 5x, you can check that you factored it correctly. That's one really nice part about factoring. All right, let's do another one. Okay, one more time. How do I know that I have to use the product rule? It's two terms being multiplied. They both have an x in it. It's not just a coefficient. So we have f. I'll drop the colors now. 6x to the 5th. F prime will be 30x to the 4th. S will be the ln of x. And s prime will be 1 over x. So y prime is equal to f prime s plus fs prime. So y prime equals, cross cross, 30x to the 4th ln of x plus 6x to the 5th, 1 over x. But that means that in the second term, what this is right here, I'll write on the side, is 6x to the 5th over x. So this x is going to cancel out with one of these x's. So I have y prime is equal to 30x to the 4th ln of x plus 6x to the 4th. But I see a greatest common factor I can factor out. From 6 and 30, I can take out a 6, and I can take out an x to the 4th. So in the first term, I'll be left with 5 ln of x, because if I take out a 6 from 30, I'm left with 5, and I took out all the x's. And from the last term, I'm left with a 1. It's not 0, right? Because remember, when you distribute it back in, it has to become 6x to the 4th. So if you can factor out everything, you're left with a 1, not a 0. And here's my factored form. All right, one more. So in the last video, we did find the equation of the tangent line. And in this video, we're going to say where the tangent line is horizontal. So remember, in this one, it switches. It gives you m by telling you that the tangent line is horizontal, which means m is 0. And it asks you what x is. But m is the derivative. So the first thing you need to do, tangent line, derivative, 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 you need to find the derivative. And if I look at my derivative, I'm going to use the product rule. But also, if you actually wanted to, you could distribute it first, but you're still going to have to use the product rule. Because if you distribute it first, the first term is still going to have two terms. It's still going to have an x and an e. So here it's better to actually just use the product rule. So my first is x minus 3. My f prime is just 1. Then my s is e to the 2x. And my s prime is 2e to the 2x. So f prime of x is equal to f prime s plus fs prime equals, I'll make some room for myself, cross cross, 1 times e to the 2x, so I'll just write directly e to the 2x, plus x minus 3, 2e to the 2x. Now, I'm going to simplify this because I can see that in this term and this term, I do have a common factor of e to the 2x. So I'm going to pull out the e to the 2x. In the first term, I'll be left with the 1. And in the second term, I'm actually going to put the 2 in front of the x minus 3. Because remember that 3 times 4 is the same thing as 4 times 3. So they're being multiplied. I can switch the order. And then I'm going to clean up the inside a little bit by distributing the 2, 2x minus 6. and combining like terms, which is going to give me 2x minus 5. So my final derivative is f prime of x is equal to e to the 2x minus 5. Now that I have my derivative is my slope, so I set it equal to 0. And this is why in one of the situations, it's really important to have it in factored form, because when you have it equal to 0, you need to set each factor equal to 0. So I have e to the 2x is equal to 0. I sometimes really see people forgetting setting e to the 2x equal to 0. It's very important. Each term gets set to 0, and then 2x minus 5 is equal to 0. Now for the e, I need to ln both sides to get rid of the e. So that will give me 2x is equal to the ln of 0, which means that x is equal to the ln of 0 over 2. But the ln of 0 is impossible. It's not part of the domain. You can try it in your calculator. It's an error. It doesn't exist. So this doesn't give you any solutions. And then this one is pretty easier to solve. It's just linear. You add 5, divide by 2. So only one of the factors gives you a solution, and it's the second one. So you only have one x where the tangent line is horizontal. So on the graph, at 5/2, the tangent line will sit nice snug onto the graph and be horizontal, and that will be the only place. So there's only 2 steps to this question. First, you find the derivative. Second, you set it equal to 0.